Ladies and gentlemen, let's go over a couple of basic things you need to know about the flat Earth. Let's start with how the Earth looks. As you can see, this is a disc shaped object. Now, people would say, oh, come on, without gravity, you would just float away. Well, no, because this disc is traveling up at a velocity very high, very high. Um, and as you can see, here it is. So that's a disk. It's traveling up with a certain velocity, and this creates a force on somebody in the upwards direction, and the normal force would be at the downwards direction, as we know, which is keeping you on the Earth, obviously. So we know force equals mass times acceleration due to gravity. So we would say a small g, but once again, gravity is not true. So instead of the small g, we replace it with the Gilson theorem, which uses the Greek letter nu, which is like a V. That was terribly drawn. Kind of like that, with a little tail at the end. So that is what the Gilson theorem is. It just replaces the small g with the what's it called? With the new Greek letter. Um, and as we know, the force you exert on the disk is the same the disk exerts on you. So say you have a mass of whatever 10, and acceleration we all know is 9.8, as we but as we know, the Gilson is the Gilson is equal to 9.8. So 10 times 9.8, 90 or 98.0 newtons. Or we could also write it in Gilsons. They replaced the N with the Gilsons. So that is what that looks like. But as you could probably ask, um, how is it that it's exerting a force on you if it is going in with no acceleration upwards? Well, that's wrong. It's going with a very small acceleration upwards. The mass is very big, so the mass is big, and the acceleration is small. Acceleration due to the Gilson theorem is very small. So that explains how you're staying on the ground and not floating away. Okay, and we will get to some other parts in just a second.